Hello, and welcome to our module on the scientific method. It's an impressive name, and the progress in science is never smooth. However, when all is said and done, everything does fall into an organized, logical sequence. My narration of these slides can be followed on the accompanying document. Please add your own questions and comments to these notes, so if you don't understand something, you can ask. It's been found if students write their own notes by hand, that they remember and understand things better. These are the basic terms we use when discussing the scientific method: observations, hypotheses, laws, and theories. Terms you will not see include fact and proof. In science, the word theory has a very definite meaning, different than it does in everyday conversation. When most people say theory when discussing what they believe, what they actually mean is hypothesis. A theory is much more grounded in evidence than a hypothesis is. We all know that a cereal gets soggy when it sits in milk. Here, Hammy has a question he wants to answer. He's going to do an experiment to test out a hypothesis. Either his head will stay crunchy when he soaks it in milk, or his head will get soggy. There are actually two hypotheses that he gets to test out. One is shown to be true, the other is false. This slide shows a good overview of how one develops and tests a hypothesis. Many people have high blood pressure. Let's use testing why one may have it as an example. One might propose a number of reasons: stress, smoking, being overweight, too much salt in the diet, age. Well, the last will be hard to test for. What we need to do is to take one of those possibilities at a time and remove it from our lives, all the while monitoring our blood pressure on a regular basis. So we've identified the problem: we have high blood pressure. So let's tackle too much salt in the diet. So for the next couple weeks, let's cut out the chips and see how our blood pressure responds. After a couple weeks, we take a look at our blood pressure readings. They're down. Yay! Question answered. They haven't moved? Choose another possibility and repeat. Hopefully we'll find an answer and be the healthier for it. Besides observation, these are the terms you need to know and understand to get a grasp of the scientific method. Just read them for now. We've already seen a couple examples of hypotheses and their testing. We will cover law and theory next. Scientific laws are statements of truth that we don't have any exceptions to. The law of conservation of matter, stating that matter can neither be created nor destroyed, is one of the two laws that chemistry is based on. The law of conservation of energy, or that energy can neither be created nor destroyed, is one of the laws that the study of thermodynamics is based on. Both of these are still taken as true in our macroscopic world. When taking into account the decay of an atomic nucleus, Einstein combined these laws into the law of conservation of energy and matter when he derived the equation E equals mc squared, or the equation that tells us about the energy involved when mass is converted into energy. Notice, though, that these statements are concise, can pretty much be expressed in terms of a single mathematical equation, are universally accepted as true, but do not give an explanation why something is going on. Theories are referred to as scientific models. They are much more complex than most hypotheses and are science's best explanations of a subject at a particular point in time. They attempt to explain a set of related observations or events that are based on a number of hypotheses shown to be true because they were generally verified by a number of research groups. Theories are complex and dynamic. By dynamic, we mean they are subject to change as more information is gathered. Unlike laws, theories do attempt to provide a why or how answer to a scientific question. For this reason, they are often referred to as models. On this slide is a list of a number of theories. Note how general the topics are. Germ theory, or how various types of germs such as viruses, bacteria, or parasites cause diseases in more complicated organisms. Atomic theory, or what constitutes the most basic element of matter. Cell theory, or how cells are made up and how they reproduce. Continental drift, or how our globe came to look the way it does. Don't memorize the list. If you want a longer but still brief explanation of any of these theories, go to the Wikipedia page and read their introductions. In science, one can generally trust what is written in Wikipedia. Throughout this semester, we will be looking at the evolution of atomic theory. The Greeks were the first to think about the nature of matter over 2,000 years ago, but it was a philosophical exercise without the experimentation involved in science. It's only since about 1800 that scientific theories on the nature of matter were first proposed, and the theory is still being refined by chemists and physicists today. This slide is meant to emphasize the difference between two words that are often used interchangeably by the public when they really shouldn't be. Hypotheses are tentative explanations of certain facts that generally provide a basis to do further experimentation on a particular subject. Theories are much more involved and have much more evidence behind them. They are explanations of general principles, often bringing two or more sciences together and have considerable evidence to support them. Still, theories are not the last word. They are subject to change as more work on them is done. When you do your homework, please think about the questions as you answer them. The object is not just to get the points for the homework, but to use the homework to understand the material and prepare for the tests.